everyone. My name is Modise, and I'll be presenting my progress on my DN on model for predicting energy consumption and carbon emission for automotive manufacturers. Climate change is moving faster than we are, and energy consumption is the main cause. As you know, that in South Africa, 95% of our energy comes from coal, and which the end product of that is carbon emission. So definitely there is a challenge in terms of our energy. Next slide. So, this according to AABC report, that automotive companies consume about 52% of electricity. Of that 52, we get 65% carbon dioxide from that. So my focus is actually on that specific component manufacturing, assembly plants, and all that. Next. All right. This study was done by the. No, can you go back? Only this one. Okay. So if you look here, this is a study from a climate action tracker where they are saying that South Africa, we're not on track in terms of our climate change targets. The target, we actually volunteered as South Africa to reduce the emission by 34% in 2020, and then also 42% in 2025. So definitely we are not on track. But this study was done in 2019. But if you look at the numbers last year, I was listening in the radio 3 weeks ago, they're saying that actually due to COVID, our emissions, we actually emitted less because obviously industries, they were not working. So those numbers might be different now, but there's no data yet. Next. So, South Africa Automotive Master Plan 2035. It has actually addressed the following challenges that are there. One, which is global competitiveness of our local manufacturers. Two, transformation. Three, sustainability. So my focus is on the sustainability. Sustainability number 7 and number 9 and 13, which speak to infrastructure and innovation, clean energy, and also climate change. So definitely these are the areas that, as we know, that the SDs are very important currently. And also on the left-hand side, if you look at number 5, it's industry infrastructure. And energy is one of the industry infrastructure that needs to be looked at. Next. Solution, incremental and architectural innovation. So a little bit background about this. When I came to study the DN, the objective was that the solution that I'm going to come up with, it has to be the solution that has to be implemented in the industry. So the research must not go back to the libraries and gather dust today. So basically here what happened was that there's a device that has been developed. It's been developed by TUT students, and it was patented. However, what's happening with this device, the current objective of the device, where it's sitting, it only provides data on energy consumption. So in terms of your load and all that. However, what is happening now, we're integrating the 4IR within the device that you are able to actually capture information from different machines and all that. And the study, my study will then develop software in terms of the projection on the energy and carbon. And then based on that, then you are able to manage your energy and carbon. All right, on the benefits of the device is adaptable to the existing electricity infrastructure. 2, you can actually monitor the data remotely. 3, there is a rebate from DMRR, the Department of Mineral and Energy, of 5% if you save a specific a percentage of energy, and it's flexible. Also, it will assist you with the data for tax reporting. So, with the first point, actually the device is designed in such a way that it takes up to 120 sensors for bigger plants. However, it can be customized to different needs of every company. Right? When Molalo spoke earlier on, she spoke about, and Dr. Kanagana, she spoke about a triple helix model. So with the triple helix model, like they said, the university, government, and the industry. But where is the SMME? I put the SMME there because the SMME needs to be supported to actually be able to be able and support the industry. Okay, next. So, where are we in terms of the implementation of that specific device that I've just shown you, the technology? 1, TRL level 1 and 2 and 3 is done, and then TRL level 4, 5 is done. However, in terms of that TRL level 4 and 5 and 6, we actually adding that element of incremental and architectural innovation. And then commercialization, there is already a company that is available for commercializing the technology. And then also, the incubator is available also to assist the company. This specific technology with that specific company has already won an innovation award, a 4th prize of innovation award with Innovation Hub. All right, like I said, it's an incremental architectural innovation. So it's not new innovation that is going to be adding on what is already existing. Okay, next. All right, the study now. 1 is to identify relevant policies and set targets by climate change, agreements for energy efficiency and for energy efficiency of production industries, and carbon emission signatures on manufactured products. 2 is to investigate hybrid, embedded energy efficiency and carbon dioxide emission model to improve resource efficiency in transport manufacturing on the product design. 3, to explore different analytical methods for predictive to reduce energy consumption and advise on hybrid embedded energy and carbon emission efficiency for national reporting system for future transport manufacturing and greenhouse gas emissions. Number 5, this is the final product of this specific, just correct, the objective, this is the final product where we're going to have a web-based model with a real-time data, and also we're looking into developing an app. Okay, next. So in relation to objective 1, this slide is a little bit blurry, but here what I'm showing here is that all the orange is what has been done globally, and then the black, if you look at the black, Now the technology. If you look here, energy efficiency was introduced in 1980 in the EU countries. And then now in South Africa it was only in 2008. So you can see the gap. So we're still actually way behind. And then carbon emission policy was introduced in 1995. Only in 2019 in South Africa, carbon policy and implementation was actually approved. But the talks have started earlier on in 2013. Next. All right, methodology. My methodology is responding to the fourth question, which what is the analytical method that can be used to advise decision makers on national reporting system for future transport manufacturing for predicting hybrid embedded energy and carbon efficiency. So I looked into different studies and time series because of the data that is collected, and especially for automotive sector and projection and prediction. Time series was relevant, one. And then I said, you know what, I'm going to look at statistical method and machine learning method. So I went ahead and looked at statistical methods which are relevant to projection and they've been mostly applied, and then the machine learning as well. And then once I've done that, then I said, is it possible to actually combine this so that we have sort of concrete or positive results out of the two? Because statistically it was more linear, and then the machine learning it was on non-linear. So with the statistical, I looked at autoregressive integrated moving average, which is ARIMA, and then also on the machine learning was artificial neural network. Then I said, okay, fine. I will combine the two because I looked at the weakness of the other one to complement the other one so that we can come up with a hybrid model. Okay. So with the data, the first step is to use a RIMA model to analyze the data that is available. And then once you've done that, then you take the artificial neural network model, then you start developing the model from the residual that came out of ARIMA. Then, since ARIMA model cannot capture the non-linear structure of the data, the residual of linear model will contain, some of the information will contain non-linear. So the results from that can be used as a prediction of the error in terms of the ARIMA model, and the hybrid model, and then exploit unique features of both strength and both strength of ARIMA as well as ANN. Can continue. All right. I've got data, I see. So I've got data that I've already collected. However, I have not gone deep into analyzing that data. I've just started with the initial steps because basically when you get the data, what you do, you first graph and see what the data gives you. Once you've done that, and then now you start applying your mind and the models and the equations on that, so that I'm not there yet. Hence I said that it's a work in progress. This is the team. You know, I'm not going to take any credit on most of the things, especially on the device. The device has been there, and the device has been developed by the team with Dr. Adenuga, and also Professor Mpofu is there, and then we've got Tobelani. He's coming up. He's currently doing his BTech. He's finalizing that, and then that's me there. Energy efficiency and carbon emission are the main cause of the climate change. The manufacturing sector contributes a high percentage of energy consumption. The purpose of the study is to select relevant time series techniques of carbon emission and based on the energy consumption. All right, yeah, that's it. All right, the significance of the study, I think, yeah, we all see that. However, at the end as well, we're going to develop, actually I've started developing the SLP around ISO 15001, which is related to energy management system, energy efficiency as well. Also, I will look into developing a guideline on tax reporting, SLP on tax reporting, especially for the SMMEs. Right, next. All right, next. No, I needed to acknowledge him because he's my study partner.